All right, so kind of backing off what we were doing yesterday. Yesterday we talked about total area under that curve was equal to 1. So now we can apply it to some probability questions, knowing that the total of all of our probabilities is equal to 1. So that's what we're going to start with. For the first set of problems, we have z-scores. Okay, so we want to find the probability that a z-score is greater than negative 1.85. If you have a z-score, we look it up on the z-score chart. Okay, so purple packet. I don't know where I put mine. Let's see where I put mine. Must have carried it somewhere. Okay, so we're going to find negative 1.85. And that's going to be on the negative side of our chart. Negative 1.8 down the side. 5 along the top. And we are going to find the corresponding area that goes with that number. So let's see, negative 1.85, we get 0.0322. Okay, and remember, whatever number we get on our chart is the area to the left or a less than scenario. So that's what we have right now. So if I want to change it to a greater than scenario or an area to the right, how did we do that yesterday? We did 1 minus, and that's it. All right, so 1 minus 0.0322 gives me 0.9678. And then you could also make that a percent if you wanted to. MathXL asked for it. There is a 96.78% chance that you will have a z-score greater than negative 1.85 on any given normal curve. Okay, find the probability that z is less than negative 0.18. Okay, so now because we have less than, we just use the number directly off of our chart, and that's it. So negative 0.1, and then I'm going to go over to 8. I get 0.4286, and that's it. 0.4286. Okay. Last one, find the probability that our z-score is between 0 and 0.525. 0 is one that you probably do not need to look up. If you have a z-score of 0, where are you on a bell curve? In the middle. So what's the probability or the area to the left? It's 0.5. And if you look it up on your chart, if you find 0.00, it's going to be 0.5000, which is 50%. Okay. We do need to look up 0.525. Now this guy has an extra decimal place. So what we need to look at are 0.52 and 0.53, the numbers on either side of it, and then find what's in between those. Find the midpoint or the average. Okay. So if I look up 0.52, let's see. 0.52 is 0.6985. If I look up 0.53, I get 0.7019. And then add them up and divide by 2. That's the probability that we're going to be looking for on that one. 0.7002. Okay, so the probability that I'm less than the guy on the right is about 0.7. Probability that I'm less than 0 is about 0.5. How do I find the probability that I'm between them? What do we do with those two numbers from yesterday? Just subtract them. So 0.7002, bigger minus smaller, minus 0.5 gives me 0.2002, or about 20% is that probability that I'll have a z-score between those numbers. Okay? Any questions on those, using these areas as probabilities? All right. The next slide isn't on your paper. You might want to write it down just like in the margin somewhere. This is a review formula that we use in Chapter 2. This is our z-score formula. It's how we convert an x value, a data value, into a z-score. And then that allows us to find that probability or area that we're looking for. So x is our score or our data value minus our mean divided by our standard deviation. Remember, this is what the formula looks like if it's written with population symbols. It could also be written with an x bar for mean and an s for sample. But for right now, we're going to be sticking with these. Okay. All right, so the rest of the problems today then are going to have kind of this procedure. We're going to have an x value that we're going to need to convert to a z-score. And then we're going to use that z-score and our charts to answer whatever question they're asking about with probabilities. Okay. So First problem. A national study found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9 hours. A college student with a job is selected at random. Find the probability that a student works for less than 4 hours per week. Assume that the lengths of time college students work are normally distributed and are represented by the variable x. You're going to see assume everything is normally distributed in every problem that we do in this chapter. Everything has to be normally distributed to use our z-scores because our z chart is our normal distribution chart, okay? So that's just kind of like clarifying, hey, we can do what we want to do on this. All right, information that I'm given. I am given that the mean or the average is 22. I am given that my standard deviation is 9. And I am calculating the probability that, in this case, the length of time, x, is less than 4 hours per week. Okay, so that's the problem that we're answering. Sometimes it is tempting if you have a number, like let's pretend that x was less than, I don't know, 2.1 or something. If you have a number that's on this chart, it is tempting to want to go straight to the chart. Okay, but remember, you cannot use this unless you have a z-score. Currently, we do not have a z-score. So first, we need to take that x value of 4, and we need to convert it. Okay, so to calculate my z-score, it's always x minus the mean divided by the standard deviation. Okay, my x is 4, and all the x is less than that, minus my mean, 22, divided by my standard deviation is 9. So it's going to be negative 18 over 9. It's going to be negative 2. Okay, so now the problem isn't find the probability that x is less than 4. It's find the probability that my z-score is less than negative 2. And as soon as I can write that question in terms of z, I can use my chart to answer the question. Okay, so we're going to find z-score of negative 2 or negative 2.00 is what you guys are looking for. So let's see, that is 0.0228. And that's it. Okay? Any questions on that problem? All right, flip it over. Let's do another one. A survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed and are represented by the variable x. A shopper enters the store. Find the probability that the shopper will be in the store between 22 and 52 minutes and more than 37 minutes. And then we're going to use that information to figure out if 200 shoppers enter the store, about how many would we expect to be in there for that length of time. Okay, so let's start. We have x values for each of these. Okay, so we have an x value of 22, an x value of 52, an x value of 37. I can't do a whole lot with x values. I need z-scores to be able to find my probability. So there's going to be 3 z-scores that we need to calculate. You can kind of do them all at once if you want to at the beginning here. Okay, so I need to convert 22 to a z-score, 52 to a z-score, and 37 to a z-score. And to do that, we need to take that x value, again, subtract the mean, divide by the standard deviation. In this case, the mean or the average was 43, so minus 43, and then divide by my standard deviation, 12. And you're going to do the same calculation for each of them. Minus 43, divide by 12. Minus 43, divide by 12. And I think these ones are going to work out pretty decently, but if you need to, we just rounded 2 decimal places because that's the further our z-score chart goes. Okay, so 22 minus 43 over 12. For the first one, I get a z-score of negative 1.75. 52 minus 43 over 12 gives me positive 0.75. And my last one gives me negative 0.5, or if you want those 2 decimal places, 0.50. Okay. All right, so now let's go ahead and write what we're actually calculating here. So for the first problem, we're trying to figure out what's the probability that someone will be there between 22 and 52 minutes. Or what's the probability that they will have a z-score that corresponds to those 2 numbers, which in this case was negative 1.75 to 0.75. Okay, and we know if we're calculating a z-score between two numbers or probability between two z-scores, we want to do bigger minus smaller. So I'm going to look up the bigger one first, which is always going to be the positive one because that guy's further to the right on my curve. So 0.75, if I look up that cumulative area or cumulative probability, I get 0.7734. If I look up negative 1.75, which will be the smaller one, it's further to the left, 0.0401, and then we subtract them. 0.7333 is the probability that when someone enters the store, they will be in the store between 22 and 52 minutes. Okay. For number 2, we are finding the probability that they are in there for more than 37 minutes, or when we convert that to a z-score, that the z-score is, because it's more than, greater than 0.5, negative 0.5. All right, if I look up negative 0.5, I get 0.3085. And then actually leave a little space because it's greater than, I'm going to do 1 minus to get my final answer on that one. 0.6915 is that probability. Okay, so x to z to probability. All right, the second part of the question said, using that information now, if 200 shoppers enter the store, about how many shoppers would you expect to be in the store for that interval of time? So if we know about 73% of shoppers are going to stay in the store between 22 and 52 minutes, and now I know more, I know there's going to be 22 shoppers, I just need to figure, or 200 shoppers, I just need to figure out what is that 73% of the 200 shoppers. And if we say of in math, we're multiplying. So we're just going to take that times 200. And I get to the nearest person, I get 146.66. So I'm going to say about 147 shoppers. So if 200 people enter the store, we can expect that about 147 of them are going to stay in the store between 22 and 52 minutes, according to this model. And you do the same thing for the bottom one, okay? We know it's about 69%. If we know there's 200 people, that's about 138 shoppers. Okay. All right, last one on your paper is for you to try. It's about Major League Baseball batting average, I think. See if you can answer that question. And then I'll put it on the board. You can check your answer in a couple minutes. All right. When you're ready, want to check it? All right. What questions do we have on this problem? Anything? I'll leave that up there for you to check. Okay, exit tickets. Work together on it. Turn your own in the tray, and the rest of the period is yours. And remember, tomorrow is a work day. 5-1 Math Excel is due tomorrow night, and then this 5-2 Math Excel is due on Friday night. You might be able to get both of them done in class. Pretty short. Math Excel. A little hints for a couple questions on here. So in all the problems we did today, we took an X, a data value, we turned it into a Z-score, and then from there we got a probability, which could be a percent also, right? Okay, so we went in that direction. You can't go backwards. You can have a percent, use your chart to find the Z-score that goes with that percent, and then figure out what X value that is. Do this in the opposite order. There might be a couple questions that go backwards. Okay. For both of them, they can work together. Yeah. Okay. I'll do cell phone lotto, and the rest of the period is yours. Let me know if you have questions on your exit ticket. We're working on it.